Okay, in this example, we want to investigate a linear approximation to the square root of 3.9. So what does that mean? We want to find a tangent line and use that to plug in some number 3.9. And then we want to see, is that approximation an overestimate or an underestimate? We'd like to find the absolute error, and then we'd also like to find the percentage error. So the first two things we can do without a calculator. The last two things, we will need a calculator in order to determine these quantities. So here's a picture of what it is we're trying to do. So here's the square root function, and we're looking for the value of the square root of 3.9. So that's this dot here, and that's f of 3.9. Now what we're going to do is find the equation of the tangent line. That we can do easily without a calculator, and then we want to plug in the number 3.9 into the tangent line. As you can see, these two quantities are very close together, so the linear approximation is a very good estimate to the actual value of the function at 3.9. In other words, the line here will give us a good approximation to the square root of 3.9. And now 3.9 is very close to a good anchor point, namely x equals 4, or a equals 4 in this case. And we can easily compute the square root of 4 no problem without a calculator. So that might be why 4 is a good anchor point, because we can easily compute it. Anyway, so let's go through items A through D, and let's keep this picture in mind while we go through those things. Okay, so for parts A and B, we want to find the linear approximation for the square root of 3.9, or we want to use a linear approximation to estimate the square root of 3.9. So in any one of these problems, step number one is always find the equation of the tangent line. We know how to do that. So here I want to let f of x be the square root function, because we're trying to find the square root of a thing, the square root of 3.9. And then I'll take the good anchor point to be a equals 4. 3.9 is very close to 4, and it's easy to compute the square root of 4 and the derivative of this function at 4 as well. Anyway, so if we know that f of x is square root of x, then you can write this thing as x to the 1/2. Take the derivative, you get 1/2 x to the negative 1/2. That's the same thing as 1/2 times the square root of x. So now you're going to plug in the anchor point 4 into the derivative. So when you do, you get 1/4. And then again, plug the anchor point into the function itself. And when you do, the square root of 4, we know that that is equal to 2. So here is the equation of the tangent line. 1/4 x minus 4 plus 2. And so I'm just going to plug 3.9 right into this thing. So f of 3.9, the square root of 3.9, is approximately equal to L of 3.9, and that is 1/4 3.9 minus 4 plus 2. So you work this out. This is really negative 0.1, which is negative 1/10, and then times 1/4, that's negative 1/40. So this thing is really just 2 minus 1/40. So you can work that out without a calculator, and you get 79/40. So this would be a good approximation for the square root of 3.9. Later on in the next part, we'll get a decimal representation for this thing. Maybe that'll give us a better handle for what this number is. So again, this is a good final answer for part A. If you were answering on an exam, a ratio of 2 whole numbers would be good enough. Now, is this estimate, or this approximation, is it an overestimate or an underestimate? So you can see the square root of x is always what we call concave down. You can think of it as spilling water. And so the tangent line always sits above the curve. So that means the tangent line is bigger than the curve, and since we use the tangent line to approximate the curve, we will say that in this case, we have an overestimate because the line is what we use for the approximation, and that's greater than what we get when we plug that 3.9 into the square root function. So usually you can answer the overestimate, underestimate question just by drawing a quick sketch of the curve together with the tangent line. All right, so these last two parts are just to get a better idea of how well this approximation is working. So the actual calculator value of the square root of 3.9 is roughly 1.974841. So that's this dot right here. That's the actual value of the square root of 3.9. And then the approximated value of the square root of 3.9, we just took that 3.9 and plugged it into the tangent line, and we got 1.975. That was that 79 over 80 that we got. And so that's this point on the line, and so the distance between these 2 points is the error. It's the error of the approximation at 3.9. So we just look at the absolute value of the difference of these two things, and so when we do, we get 0.000158. So I needed a calculator for this part, and I suppose we needed a calculator for this part, and then you know, we could use a calculator for this part. So this would be a good final answer for the absolute error. What about the percentage error? So we just want to take this thing and we can divide it by the actual value. So we want to take the little sliver here and divide it by this whole quantity here. So it's the ratio of this tiny little bit to this whole bit, and we want to express that as a percentage. So the tiny little bit we got was 0.000158. The actual value that we got, 1.974, blah, blah, blah. So divide on a calculator and then multiply by 100, and this is what you get for the final answer. So I should say, yeah, we want to take all this and multiply by 100. So this would be a good final answer for the percentage error. And we can see that this approximation is really pretty good. To only be off by 0.008%, that's a pretty good approximation.